to Shubhankit. Okay. So Shubhankit, I would just like to introduce you first to the crowd that he is a machine learning engineer. He's having overall 4 years of experience of Brox, and he has worked as a data scientist as well as a machine learning engineer, and he's really enthusiastic in sharing his knowledge upon bridging the gap of exploring evolution of deep natural networks and cognitive science towards human-like machines, right? So over to you, Shubhankit. Thank you.
Is this working properly? Okay. So first of all, thank you Ajay Elva for giving me this opportunity. Yesterday, a day before yesterday, I was preparing for my presentation, and I just went through the other speakers list, and I saw that all of the people are here, are way more experienced than me, and all the people who are speaking, I specifically saw one person. I'd like to meet him if he's here. That he has more experience than my age. Right, so I was quite overwhelmed first, but then I thought, okay, let's make most of this opportunity. And when I stand here today, I feel proud, and I feel a lot of prestigious as well. So yeah, with that, I'll start my topic, right? So bridging the gap, exploring evolution of deep neural networks, cognitive science towards human-like machine. To be honest, I used AI to create this presentation. What I think is, this is what one of my manager told me one day, that when you have a presentation, people take you more seriously, right? So that's the only reason for this presentation. Everything that I'll be talking, will be coming from me, and I'll use a presentation to pick up some points or experience some points if I miss them. Okay. So Jasleen, can we go to the next slide? Yeah. Thank you. Okay. So first of all, in this presentation, we learn about cognitive science. So cognitive science is basically more of a interdisciplinary field. It's not one field. It's a mixture of different fields, right? It's a mixture of psychology. It's a mixture of neuroscience, and it's a mixture of artificial intelligence as well. In easy terms, you can say that cognitive science is something which tells you how computation happens in human brain, right? So the idea is that in current AI system that we have data, and we feed that data into AI models. And what happens, like in easy term, what you can say that it forms a function. It forms a function of any algorithm, right? So whatever is happening outside, for example, if I'm predicting, let's say, loan applications, right? So if I'm predicting whether a particular loan application will get approved or not, so there is certain logic behind that. And what happens in AI is that when we feed the data, it tries to form that formula that can predict it. So when it's predicting, it's actually just trying to approach a formula that is 100% accurate. Right? That is the only idea of data science. I always think that data science is an extended version of machine learning, where we include a business side as well. And when we talk about AI, you can say it's more extended version of machine learning, where you include more complex algorithm. Right? That's the only difference. When I teach, I see people get confused with that. Okay, what's the difference between data science, AI, machine learning? So just to give you a context of that. So the goal of this presentation is to make you understand and give you some views on what will happen if we can include cognitive science to its full extent into a current artificial intelligence scenario. So just to give you a brief here, so deep neural networks, which is kind of a replication of our human mind into a machine learning algorithm, are kind of not a new thing, although they are being used recently, but they are not a new thing. Right, so the roots go back to 1943, which is, I guess, almost 80 years before now. So that time there were two people, and I don't remember the names that well, but this Warren McCulloch and Walter Pitts. These two people, they published a paper on neural networks, and the goal is that I want you to notice two things. One of them is a neuropsychologist. The other one of them is a mathematician. Right, so that is the idea. The goal is that you have to build a neural network, so you'll have to bring one person who is an experienced neuroscientist and one person who is an experienced mathematician. Now, they were not able to do something good with this, reason being that we didn't had any good technical advancement. We didn't had any computers that time which can do that much of a computation that we can do right now. So later, as technology advanced, and we knew that, okay, 1980 something, we published our first neural network, which were actually based on computation and was doing some good things. But I want you to understand that how neuroscientist is more important here, right? And because that is the root of cognitive science. That is why we are trying to include cognitive science here. So what is cognitive science? This is a new term, right? So when I developed my interest in data science, it was more of because of philosophy and human behavior and understanding those things, right? So I was good in social studies, and then I went into a race of chasing IIT dreams. So I left social studies, and when I get into college, I wanted to understand more about like presentation skills, or more about people skills and those things. So I joined the dramatic society of my college, and there I learned again about social behavior, social science. When I was learning theaters, it was not that I was a big an actor, but I was just learning theaters for a bit of time. So that time they told us, notice people's behavior, how people react, and all those things. So that got my interest back into a bit of human psychology and all that thing. And when I started learning machine learning part, I learned machine learning on pen and paper. I had a lot fear of coding, so I learned all machine learning on pen and paper first, and then I dived into the world of data science. So I was always interested in the human psychology part of data science, because data science is just using data to predict something, but when it comes to actual use, we have to look towards human behavior, how people react to different notifications that we got. You must have seen different notifications from Zomato and Swiggy, which are quite customized and which are quite interesting nowadays. And those all are based on human psychology, because you know that if they'll give us a simple notification, hey, Zomato has a 50% discount or Swiggy has a 40% discount, like you are less likely to open it. But if they give you, quite an interactive one, quite a one that you have to notice, something that is more related to what is happening currently in the market, you will relate it to more, right? So you are more prone to click on that notification. So the idea from cognitive science comes from that only, right? Cognitive science is not one field, it's an interdisciplinary field of multiple fields: psychology, neuroscience, linguistics, philosophy, and artificial intelligence. Now, when we approach the idea of building a machine that can replicate human behavior, we encounter some points here, right? So when you mimic human perception, cognitive science helps you overcome some points, and these are those points that we can overcome. First of all, emotional complexity. Emotional complexity is something, see, for example, if you want to build a robot like me who can come here and speak on this topic, so if you want it to be just like me, you'll have to include my emotional side as well, and there's no way to include emotional side in machine learning, right? So that is one thing that cognitive science can help us include into machine learning part, is that cognitive science insights into human emotions and crucial for developing machine learning models that attempt to mimic these complex and unpredictable patterns. Next thing is contextual understanding. Contextual understanding is like giving you a basic idea. Now you would be thinking that Shubhankiti just told us that artificial intelligence is built on data. So when you are giving it data, you are giving it some experience, right? So you are giving it some context. So what is this context then? This context is a bit different. This is more of a sociological context, and you will see that although artificial intelligence is trying to predict some pattern in the data, but there is some context that is more of a social behavior, that context that is not present in our data. For example, let's say I'm predicting a loan application again, and I want to include a context in it that there is some social thing happening out there, which I want to include in my loan application. For example, today I just saw some news that Air India has a offer going on right now for first time voters, right? So that is one new thing that they have to include in their pricing model, right? So that is the contextual understanding. Similarly, there are other contextual understanding that we cannot directly integrate into AI model as a data. We'll have to use cognitive science to integrate that thing into AI model. Next thing is your ethical judgment. Now, ethical judgment is important because this is more related to morality as well. And when it comes to morality, humans are never wrong, right? So my mother used to say this one thing that like it's a simple thing. हर आदमी को लगता है कि वो समझदार है, right? So you are never wrong. For example, I'll just give you one example. If I am there in a traffic, right, and if there's a kid out there who asks money to me, right, just like he's not asking thousands, right? He'll just ask 10 or 20 rupees to me. If I give it, that's okay, and I feel okay, I've done a good deed. And let's say I have a friend with me who thinks that if you give them money, they'll misuse it. So he's also right according to him, right? So that thinking, including that thinking in a AI model where both of these people are right, and people think that they have done a smart thing instead of doing a cunning thing, right? Nobody wants to be called a cunning person, they always want to be called a smart person. So you have to include that thing as well, and that comes under ethical judgment. And all of these points, cognitive science can help us include into AI model, and these points are not included in our traditional data science, right? When we include data in as an experience to a model, it just find patterns in that, it just try to form a formula in that, and if we can include these things, it will be a remarkable achievement for human. Next thing is learning from human memory. So now when we have discussed what all points we have to include, next thing is how we can include that. So if we want to replicate that thing, we can copy it from the already done thing. And for that, our mind has already done the same thing for us, right? And this is how it has done it, that like I'm not a biologist, guys, so I've just given you a brief idea how these things are done. So any memory, any experience, when it's stored in human brain, it has these 3 steps, that it's encoded first, then how it is stored in a memory, and then the retention and recall part. So encoding process is just that your data, whatever understanding I have, whatever, let's say I'm watching all of you here, right? So this image is somehow coded in my brain and then stored in that encoded format in some part of my brain, right? So that is a part, that encoding process is the initial learning of information. It is a critical step where perceived items are converted into construct that can be stored within the brain. Next stage comes as a memory storage. Memory storage is like once your information is encoded, how well it is stored in your brain. And when I was a kid, I used to think everything gets stored in one part of a brain. It's not like that. Our brain has different parts for each of kind of a memory, right? So I don't exactly remember, but I think one side of our brain is more practical, the other side is more towards emotional, if you divide your brain into 2 parts, right? So similarly, the kind of memories you have, it gets stored in different parts of brain, different format, and when it comes to retention and recall, they are it depends on how well you retain that memory and how well you can recall it. So this is important, right? Our brain cannot recall everything. For example, I'll recall this thing every time because I've got an opportunity to speak up here, right? But let's say I'm watching this thing on YouTube or watching this thing on some LinkedIn photo. I will not recall that much. That is the idea of retention and recall. The efficient memory storage is reflected in ability to retain and recall information. So if we want to include cognitive science into our AI model, we have to follow what our brain has already done naturally, and these are the steps that you'll have to store memory efficiently. Now, once you have stored the memory, then the part is not done. Now comes the time for action. Okay, I have stored information. Now how well I do the actions on that information. So if you will see the third point here, ideally it should have been above, but third point here, that is a human attention. So this is what currently we have in our mind, the idea of human attention. So complex cognitive function that is essential for processing sensory information and navigating the environment effectively. Basically, you have a complex cognitive function. When I say complex cognitive function, you can say we have a complex combination of neuroscience and mathematics and philosophy already prepared in our brain, and that helps us in human attention. How, like if I'm holding this thing, if I'm approaching here, if I'm approaching there, that all comes from human attention. And if we want to approach that human attention part, we have to achieve those 2 parts that we can include in our AI model, which are sustained attention and selective attention. Sustained attention, like as the name suggests, that it is like how well you remember a task for a long period of time, right? So if I have done, let's say, you can say ability to maintain focus on a specific task stimulus over a prolonged period of time. For example, let's say if I'm going into my graduation part, so it's a 4 year of graduation. I have that memory in my mind, okay, I am currently an undergrad, I'm doing this graduation for 4 years. That thing is stored in my mind and I have a different approach toward that task. Instead, let's say I have a task today, okay, I have to wake up today and I have to go to my class and attend a session. Right? That is a 24-hour memory, you can say, a day memory. And then you have a year, like 4 year long memory. So there's a difference between both of them. Next is your selective attention. Selective attention is basically how well you differentiate between relevant and irrelevant tasks. So relevant tasks are something that if I'm standing here, I'm focusing on people, I'm focusing on this PPT, this is a kind of a relevant task. Irrelevant task could be that if I'm moving in a park and I saw a tree branch hanging and I just jump and kick it, those kind of things are relevant tasks. I did that because it was irrelevant. It is not it is not important to remember that thing, it is not important to do that thing. So those will be your selective attention. So now, the purpose of this point here is that if we want to achieve cognitive science in your AI model, so I have this habit of just recalling things, connecting the dots while giving a presentation so that people can understand. So our idea is that how we can include cognitive science into our AI model. We understood what cognitive science is. Then we understood what is the idea of human perceptions there. If you want to mimic human perception, what all points we'll have to keep in mind. Then we'll understand if we want to include these points using cognitive science into our AI model, we have to replicate our memory like a human brain. And then we saw, okay, once we'll try to put this thing in action, what all challenges we'll face, and that challenges would be your action to those things in terms of sustained attention and selective attention. So, jumping to next thing would be bridging the gap. So I'll just summarize this point quickly, right? So bridging the gap here basically means that now once you have prepared this plan, how do you put that plan in action? So the idea is that, and this is just a hypothetical idea, and we are trying to achieve this thing, and you know nowadays you see models learning this thing bit by bit, right? So if you guys use ChatGPT, you will see ChatGPT understanding sarcasm. You'll see ChatGPT understanding dark jokes, right? These kind of things, which it doesn't used to do in the previous versions. And similarly, same thing goes for all models. Now, when I say bridging the gap thing, so the idea is that you try to replicate the neural networks that we have in our mind into an AI model. So it will be quite a big AI model. It will have many number of perceptrons. Perceptrons basically you can say are receptors which can detect the actions or you can say sense that action. So if you want to replicate a human brain, you will have to form a quite complex AI model. And what you will do now, you will put that AI model to social situations. You will put that AI model to social situations and you will see how it is responding to that situations. Now, you have prepared this AI model taking the idea from human brain. Till now, it is not legally allowed and people obviously not do this. They don't penetrate working human brain, right? Obviously, that will not be safe. So, till now what we have tests on animals that are close to human intelligence, such as dolphins or monkeys. And the other thing is that you have experiments on inactive brains, brains that you get from dead bodies. So what we can do now is that we can try to replicate a neural network similar to that of a human brain, and then we can train that neural network, newly built neural network, on some social conditions. And once we'll test that on social conditions, it might give good response, it might give bad response, we'll have to judge that. And now, once it has given a good response, you can now go back to see from which part of the AI model it has given that response. Because you have replicated this AI model, from a neural network, so if it is replicated properly, if this AI model has given a response from a specific part, same part would have been there in a human brain. So now this completes a cycle. You are using human brain to build your AI model, and then on the built AI model, you will be using a same AI model to retrain it again, right? So it's a bit complex process. That is why it has not been done yet, right? So, but the idea is that if you can do this thing, we will come closer to this part where AI will beat human intelligence, right? It's not a new thing, guys. I mean, people think, okay, AI will beat humanity, and it will, right? It will if we'll compete with humanity, if we'll compete with AI on a similar terms. If I'll just take a simple example, if I'll compete with a calculator, no matter how good a mathematician I am, I'll break, right? So it's that part, right? I mean, the debate, I'll just give you one simple story. So I started my YouTube channel just 2 months ago, and I prepared a lot of video on fundamentals of data science and everything that I know, just to teach young aspirants data science. But the most viewed video on my YouTube channel is on AI will take your job, because this thing is linked to everyone, right? All of us are somehow doing work that can be automated. Some part of your work can be automated. So that is the thing, people are talking about it because it's impacting your daily life, and we should So when it comes to beating human intelligence, now it's different, right? Till now AI was beating your repetitive task, your automative task, it was doing that. When it comes to beating human intelligence, this becomes different, right? Because human intelligence was something on which we humans had a pride on. Okay, we had ability to think, we had ability to build, we have ability to speak, or we only are the creatures who have ability to have our own language, and that to that many languages, right? So, but if cognitive science is included into the part of AI, we can do this. Now, when I heard first about this topic, when I thought about this topic, the first thought that I have, if this is going to take my job later, why I'm building this, right? So that is the idea. Like it's kind of I am automating a thing, and next day I'm out of my company. Okay, thank you for automating the thing that now we don't need you. So the part is that you don't need every part to do with AI. There's some parts which human cannot do, right? And we'll come to that later. But I'll just give you one example. For example, space exploration. So there are some parts where human cannot reach, but we can send an AI model there that have cognitive science, which is called, smart AI, you can say that, right? And that can take decisions for us, what we have to do in that situations, right? That's one example. I'll give you a couple of more examples later. But when it comes to beating human intelligence, the same thing that we discuss in the process of coming to here, that we'll have to consider the ethical consideration, we'll have to take that, contextual information in mind. All of those things comes as a idea, okay, same steps would be your roadblocks as well. How well you can overcome that. Once it would be done, and I'm pretty sure it would be done, right? Because we have that much of a computation. For example, let's say ChatGPT is based, I think it's trained on billions of parameters, right? So in simple machine learning algorithm, if I'm building a use case for my company, I would have like at most 60, 61 features, 62 features like that. That's what I've worked on. But ChatGPT is based on billion parameters, right? So that's just too many parameters. It can contain a lot of information in that. Now, so yeah, there's a chance to beat human intelligence, and it will be done via cognitive science. That okay, if we can include cognitive science in that. But that itself will be a big achievement to include cognitive science in that. But there is a possibility we are achieving that thing, right? If you will just try models like ChatGPT or Gemini or BART, you will see they understand sarcasm now. They understand insults now, right? So, and I use ChatGPT a lot, right? So when I put some data there and it gives me a wrong results, I kind of scold him, and then it gives me a better results instead of just, if I'll retry again, right? So if I'll tell him, hey, you idiot, give me better results next time or I'll kill you. I've tried this, guys, right? And it gives you good results, So it gives you good results because it learns that thing, okay? Whatever I am putting in my model next time, I have to put extreme values. It's all mathematics, guys. Even in your simple machine learning models, it's all mathematics. Whenever you get a prediction, that is not a 100% prediction, it's always a probability. You get a probability and you have a threshold. Each machine learning model will give you a threshold. For example, let's say if I'm predicting whether a person will get a heart disease or not, my model will give me a prediction, okay, 30% of the chances are there that the person will have a heart disease, right? And now it's up to me, it's up to me that I can put a threshold on 10%, okay, because see, if it's a 40% chance of heart disease, you are prone to a good heart disease, and that's a fatal part of it, right? You can have a really great disadvantages of heart disease. So even if there's a 10% chance, I think a person should be given, okay, this person could have a heart attack or something. So that is an idea. Coming to the next part, the road ahead, smart AI. So what will happen once we'll achieve this? So once we'll achieve this, we will gain smart AI. So when we talk about artificial intelligence, intelligence is something that our brain does. Artificially means that we have created it artificially, that is not naturally occurred, right? Including cognitive science and artificial intelligence will eventually give you smart artificial intelligence. And when I say smart, it can make decision, right? Just like my mother used to say, that nobody thinks they're cunning, they think they're smart, right? So that is a part. Smart AI refers to advanced artificial intelligence system that can learn, adapt, make decisions autonomously, closely mirroring human cognitive functions. So that is a complete idea, guys, that you can include cognitive science in that. If you want to include cognitive science in your machine learning models, you will have to have an idea of how brain works. That will act as a You can say that will act as a blueprint for you. Okay, how this thing is working, now let's try to replicate this. Still, some things could not be replicated because there is a theory. I'm not 100% sure about this theory, but I read it in a research paper that some information of our human mind is also stored in our genes, right? That cannot be replicated, right? So, for example, if you can say that I am not that much of a loud speaking or a violent person, and I think that traits comes from my mother, right? So, how can an AI learn that thing, right? So, there are some parts that that are present in human brain that will not be learned, and that is why human brain will always remain a specialized species across all the species. But if you are trying to this is just I think this is the last slide, yeah. So, the possibilities of smart AI, customized learning, right? I teach at an EdTech for data science, so I know this thing pretty well, that AI could give you customized learning. In India, there's a shortage of teachers, right? And in government school, there's a lot shortage of teachers and good quality of teachers, right? So that could be a one possibility where it can go for customized learning. What happens in our education system sometimes is that and that too in rural areas, that they don't have a proper age discrimination in classes, right? That for example, when I was 6 years old, I was in first standard. When I was 4 years old, I was in my UKG, right? So I had a proper plan there, but not every student gets that plan. And that is why if in India you will see some rural classes, some student they are 8 years old, or some student they would be 6 years old and they would be in same classes, just because their parents did that much of a research, or they're getting bare minimum education. So there you can use customized learning. Advanced healthcare, smart AI can enhance early disease detection and offer innovative solution like voice synthesis for speech impaired individuals. Another field where we have shortage, right? In India we have shortage of doctors, and that actually this thing could be replaced by a simple ML model as well. Sorry, because most of the time you will see diagnosis in India would be quite similar, right? So the doctor that my parents took me to every time used to give like 80% of the medicines was same, that I can say, right? But yeah, we need specialization there as well. So for easy things we can have advanced healthcare as well. Next year, autonomous exploration. I think I was giving explanation. Okay, if we have to explore space and there are other places where human cannot reach, you can say the depth of Antarctica, right? Those kind of places, you can use an AI model there which can go there in extreme environments, in extreme regions, and can make human-like decisions for you, right? So that was the end of our presentation. I'll just conclude it like there's a chance of AI taking our jobs, that is fine, but there's a chance of AI taking our role as a superior species as well, right? And it's all in our own hands, right? But I don't think people need to scare from it. Like we already made nuclear plants, we already made nuclear bombs, right? So if something we have to be more scared of, it will be a nuclear bombs, right? Because AI, obviously any power in wrong hands will be wrong, right? Any power in wrong hands will create disasters, but we don't need to be that much skeptical about AI, because it is an emerging field and everybody can contribute in it, right? I see many young students here, right? I see many people who want to learn AI. I see use of AI in our daily work, and I see many of my, for example, when I was in 4th year of my college, I started learning machine learning. I usually get some text from first year of my college students ki, hey boss, if I want to, they call me boss because I'm their senior, right? So if I want to be a data scientist, what path should I follow? So in first year of their college, they're thinking that particular part. So and nobody knows what will happen after 3 years. Nobody knows whether the role of data scientist would be there or not. And according to me, AI engineer is something, a new role that is coming out there, or AI product manager is a new role that is coming out there. But you still have that thought in mind, okay, I have to include this thing in my daily work life and everything. So if we include cognitive science into AI, it would create miracles for us, because it will be a huge achievement in the part of, because you're replicating nature. That is a pure replication of nature if you can include cognitive science into the part of AI, right? And there are steps to it. All the process is quite complex. The steps that we have discussed, people are working on it, and the growth is quite high. And the growth is quite high because all of us can do AI, right? even on your phone, you can run a Python code to train a machine learning model. So the power is in everyone's hands, and that is the reason the community is growing. And when the community is big, you see a faster development in that particular field. So yeah, that thing has happened, but no need to scare from it. Just need to use AI in your own work. I see people getting scared that AI will take your job. It will take your job if you're not changing your job, right? So there's no lying in that. But there's a creative part of human intelligence. I think my work has been more than 5 times productive since I've started using AI in my work instead of competing with AI. So I think that was all. Thank you all of you for giving me this opportunity again, and any questions if you want to ask.
Thank you, Shubhankit, for really great insights on cognitive science and also bridging the gap of the human. Next, I would like to welcome our next speaker of the day, Karthik Sharma. He's a serial entrepreneur with us, just encouraging the AI implementation and automation. I would like to hand over the shield rather to Karthik, just to give it to Shubhankit as a token of appreciation and gratitude. Khol diya.